All right, team. Hi, thanks for showing up for your math learning. This is a question that Raphael asked and wanted some help on. And Christian shared some fantastic ideas that use Heron's formula to work on this one. I want to show how to do this question without Heron's formula because I don't happen to have Heron's formula memorized and I don't like using Google to answer problems if I can help it. So there's another way. Okay, so first thing is to say, okay, I know that AB is 13 and AC is 15 and BC is 14. This is common to both of their solutions. Okay, so let's label these sides X and X. These are the same because these are all right angles here and two tangents that meet, and we can draw this radius as well. Okay, so we have this is Y and this is Y and this is Z and this is Z. Okay, we're going to need these lengths in just a second. All right, so X plus Y equals 13. I'm just going to pause the video and just push this forward. Okay, so we get this system of equations, and then we get these lengths, so we go ahead and put those on the diagram. If you're wondering how to do that, Raphael already knew this. He already had this as part of his ideas. So this is 7, this is making this 6, this is 8, and 8. Okay, so now we've got those. That's very useful. But now let's consider how can we find the area of the whole triangle. Okay, so to do that, I'm just going to conveniently drop a height there. And so I say, well, and I don't know what it is, so I label it H. Okay, and that's a right angle there. Ignore this 6, that does not describe this length there. Okay, it does not describe that length there. All right, so now this is what we would do. We're going to call this, we're now working in green. So this is like this green triangle here, it's length 13. Okay, this is length, I don't know what it is, it's X. This is length H. This is length 14 minus X. Okay, and this is length 15 here. Okay, so we get two different triangles. The sun, oh my goodness, the sun is crazy. Okay, this should do. All right, so I've got two triangles that I can consider here, and they share a common height H. So I'm going to get two equations and two unknowns. This is X, this is H, and this is 13. And then I have this triangle over here, which has length 15, also height H, and length X, 14 minus X. 14 minus, not X minus 14. 14 minus X. And so you can use this approach to find the height of a triangle, and you don't need Heron's formula, okay? And it's not that bad. All right, so over here, 169 is 13 squared is equal to X squared plus H squared. So in other words, H squared is equal to 169 minus X squared. Okay, but from this one, we have H squared plus 14 minus X in brackets all squared is equal to 225. That's 15 squared. Let's just get in there. So then we have H squared. I'm still not sure why. Oh, I just have that fat of a pen. Okay. Plus this one expands to 14 minus X times 14 minus X. That's 14 minus X squared is equal to 225. Okay. And so then we're going to work that this way. So H squared plus 14 times 14 is 196. 14 times minus X, and minus X times 14 is minus 28X plus X squared equals 225. Solving for H squared equals, we're going to be 225 minus 196. So that gives us 29. 29 plus 28X plus X squared. Okay, so now we're going to move that, we're going to equate these. So we have 169 minus X squared. Okay, so that's one way of expressing H squared. So if we start with H squared equals H squared, we have 169 minus x squared equals 29 plus 28x plus ax squared. This is a sign error there, of course. Because of course there's a sign error. That's a sign error in there. X minus x squared, because when I take this across, of course, it's minus x squared. I believe that mistake comes from me talking. Minus, we add x squared to both sides, and we subtract 29 from both sides, giving us 140 equals 28x, and that makes x 5. Which, if you're good at Pythagorean triples, you could have spotted. I spotted that earlier. I just want to show you this method. Okay, I knew the answer before I started. Okay, the way I knew that was because I saw that if this was 12, the height is indeed 12, and this is 5. Oh, I'm using my Pythagorean triples here at 12, and then 9. Okay, so we have a 3, 4, 5 triangle that's been scaled up over here. That's the 3 side, that's the 4 side, and that's the 5 side. Okay, and then over here you have a 5, 12, 13 vanilla triangle. Okay, so the height is 12, and the base is 14. So now we do need the area for this method. Okay, so I'm just going to remove my green stuff here because we've used that. We now know that the height is 12. We keep that one. So this is 12. Okay, so now area of the whole triangle. Is equal to 12 times 14 divided by 2 is equal to 84. Okay, Heron's formula would give you that. And then there's another trick with Heron's formula to find the radius of the incircle of the circle. But I want to show you another way to get that. Okay, so here's another way. So we divide these up, and we're going to call the radius r. R and R. We divide these up into congruent triangles, 3 sets of 2 congruent triangles. Okay, so now we know this. All right, let's just call this A1, and so this is A1, A2, A2, A3, and A3, representing the area of all 6 triangles. Okay, so that is to say the whole triangle, 84, is equal to 2A1 plus 2A2 plus 2A3. Or in other words, 42, which is life, the universe, and everything, is equal to A1 plus A2 plus A3. And then we can create an expression using R for all like A1, A2, and A3. Right? Right. Of course you can. So A1 is that first triangle, which was 7 by R. Okay, this triangle over here, base is 7 and height is R. So we have 7R on 2 plus A2 is 6R on 2, otherwise known as 3R, plus A3 is 8R on 2. Okay, so add those together. Let's multiply both sides by 2 for fun. So we're back to this. Okay, and so then we're 84 is equal to 7 plus 6 plus 8. It happens to be 21R. And then you get the radius. Okay, you divide both sides by 21. Is 4 is equal to R. Okay, there. The reason I don't have Heron's formulas memorized is I've never needed it yet. So I could Google it, but I don't remember it. So that's how I would solve this problem. It's a different method. Find the area of quadrilateral AEIF. Oh, that's just 2A1. 2A1 is easy. 2A1 is this, which is 7R, which is 28. So that's the answer to the question. You need the incircle's radius to find that. And we got it. Yeah. 7 times 4 is 28. Okay, so Just wanted to share a different way to do this problem. Hope that was fun. Bye for now, everybody.